Okay, I'm a bit late to the contest, just a few seconds late, but let me share my screen and solve the problems. It's a bi-weekly contest. Let's see how good I can do. Okay, I don't give LeetCode in general, but then I'm giving it just for my viewers so they can see and learn from me. As a pro, I thought it's my responsibility to do this. I'm just joking. I'm doing it for fun. Equal score substrings. Okay, what does that mean? The score of a string is the sum of the positions of the characters in the alphabet, whether there exists an index size such that the string can be split into two non-empty substrings, here to here having equal scores. Okay, we want this score should be equal to this score, which is nothing but this score equal to the total by 2, right? So let's just do that. Okay, let's have in total equals to 0 char c s total plus equals to c minus a plus 1. Okay, a is 1, right? So c minus a will make it like 0 to 26 plus 1 will make it like 1 to 26. Now for char cs, okay, you have a character and then you have to see if, let's say, sum equals to 0. Now you do sum plus equals to c minus a plus 1, and now you check if total equals to 2 times sum, return true, else return false. Or not else, if that never happens, it's false, right? We are brute forcing all possible I. That's the idea here. Brute force all possible I, and then see if it works or not. If it works, submit it. It got accepted. So now we are at the second question. Okay, guys, you're given an array of positive integers numbers. The Fibonacci array is a continuous sequence whose third and subsequent terms each equal to the sum of the two preceding terms. Return the length of the longest Fibonacci subarray in nums. Okay, we want to see the longest Fibonacci subarray. How can we do that? Whose third and subsequent terms. So we want the third and subsequent terms equal to that. It need not start with 1 comma 1. See, it need not start with 1 comma 1. Even this is Fibonacci. Okay, so how can we do that? Okay, if we change, so what we want, if you see what we want is indices I such that a equals to a minus 1 plus a minus 2. We want these number of indices. Okay, so let's just find those indices and then just find a number of ones. Let's say this, if this satisfies that I is 1, we want number of ones in a line. Number of ones in a line. It's a simple problem. Okay, it's like number of ones in a line. If you try to state the problem, what exactly do you want? It's all about stating it well. So mark this indices as 1. Index I, mark it as 1. If a equals to a minus 1 plus a minus 2. Okay, see, it's all about stating the problem. If you state in this way, it's all about 2 plus max contiguous ones. Okay, it's like just number of maximum ones that comes now. Okay, so what will I do? Let's say current ones is 0. Okay, for int I equals to 0, I less than n, I equals to 2, I less than n, I plus plus. Okay, I will find the value of this index. Okay, which is a of I equals to a of I minus 1 plus a of I minus 2. Okay, if that happens, then v is 1. If v is 1, then what do I do? c1 plus plus. c1 already had lost contiguous arrays. Okay, else c1 equals to 0. Okay, int answer equals to 0, answer will be max of answer comma c1. If you return answer, we are good. We are trying to get the answer plus 2 is what we should return. Okay. What have happened here? Y plus 2, we have those initial two things to write. So we submit this and then we go to the next problem. Design exam scores. What the fuck is this? Okay, let's read the problem. Alex frequently takes exams and wants to track her scores and calculate the total scores over specific time periods. Implement the exam tracker class. Initializes the exam tracker object. Void record time is common score. Alice takes a new exam at time and achieves the score. So this is recording. Total score returns an integer that represents total score of all exams taken by Alice between start time and end time. Inclusive. If there are no recorded times taken by Alice within the specific interval, so if they are made in strictly increasing order, if we can maintain prefix arrays, we can binary search and find the sum of scores, right? Simple. Because times are increasing in increasing order, right? We should just implement these two functions, okay? What do I do here? I will have a vector integer that gives me times. Vector another integer that gives me prefix array. Okay. So now what do we do? Times will be from 1 to t, right? So initially I'll just add, this is not needed, but I'm just doing it. At time 0, I'll just push 0 and then I'll also push pref dot push back of 0. I'm just adding 0 comma 0. This need not be done, okay? But I'm just doing that for no reason. So now we have this. See, this should be long, okay? Long. So now what we do? We got a new record. We push the time to times. We push the score. This is having prefix sums now, okay? So within these two times we want the indices, okay? The index that is greater than or equals to end. The last index that is greater than or equals to end. And the first index that is greater than or equals to start. Let's take that. Int L equals to lower bound of times dot begin of comma times dot end of. These are the pointers and then we are trying to bind the search using this minus times dot begin of, okay? come on, r equals to, I do upper bound. Okay, what are lower bounds and upper bounds? Try to figure them out yourself. Okay, these are just binaries. They binary search you and then they give you something. Okay, now I should just return pref of r minus 1 minus pref of l minus 1. Upper bound make sure that we have crossed that, lower bound make sure that we came to that, so we have to do this and then it works. Take whatever you are given. So this is also correct, and then we'll go to the next problem, but then it says wrong answer. Okay, this should be long. Okay, accepted. Sorry for the wrong submission. You're given a 2D array points where points of I equals to xi y represents the coordinates of the ith point on the Cartesian plane. The Manhattan distance between 2 points is this: split the endpoints into exactly two non-empty groups. The partition factor of a split is the minimum Manhattan distance among the unordered pairs that lie in the same group. So over all valid splits, we have to find maximum possible partition factor. So what is a partition factor? Is the minimum Manhattan distance among all unordered pairs that lie in the same group. What do they mean by unordered pairs? Just pairs, right? So if you group these things, okay, constraints, we have to see the constraints. Constraints are very small. Okay, because the constraints are very small, let's try to write it in a more general way. Okay, for 2 points, we have weight equals to x1 minus x2 plus y1 minus y2. Right. So, can we binary search on the answer? Okay, what does it mean if answer less than or equals to some particular val x? Means you cannot have, see, answer equals to x or not is not easy to check, but answer less than or equals to or not is easy to check. Means you cannot have any edge that is of weight greater than x in same group. Okay, so now if we are thinking about this problem, can answer be less than or equals to x? That makes it implies and implies, can you divide the group such that all edges fall in the different groups? This is bipartite matching, right? Not this is bipartite graph or not. Okay, bipartite graph means all the edges should be from different things. Okay, so the problem converts into bipartite graph if you reduce it into this question. Like if you ask answer less than or equals to x, means you have an edge of greater than x that should not be in same group. Means all the edges should be able to split it into two sets where all the edges are in different sets, then it's s, otherwise it's no. Okay, so yeah, because this is the, if you can answer less than or equals to x, you can find the maximum x such that answer is less than or equals to x. That would be your maximum possible partition factor. Okay, can partition factor less than or equals to x? You can answer. So now we solve this problem. How to solve? Uh, how to solve for this one? You do BFS. you do, I'm not explaining it well, you do BFS and then check for cycle, odd cycle. Okay, if you do BFS, non-tree edges will be either adjacent or same cycle, same level. If they are at same level, then that's an odd cycle. So we can just do BFS and then it works out. Okay, bool bipartite. Okay, and then we have edges. Define n, fight n. We have edges. Okay, once you have edges, I want to decide if it is bipartite or not. Okay, int n. Vector int used of n plus 1 comma 0. Okay, q d of n plus 1 comma 0. Initially let's keep everything 0. Okay, and then what do? We go over all vertices. Okay, we can just do zero based index here. Okay, we go over all vertices and then if not used of v, if used of v, continue. Okay, because that component is already visited. Else used of v equals to 1, add this to your set. Okay, okay, let me keep it as start vertex. Okay, for int u array of v, if not used of u, we determine d of u equals to d of v XOR 1, which is nothing but flipping the bits. All I get is even or odd, right? And then now we have all possible even or odd here. Now we are done with BFS. Now for all edges, okay, let's just check. Let's just check for all edges. Let's just check if d of v equals to d of u, return false, else return true. That's it. Means they have same level, means there is an odd cycle here. 0 1 0 1 keep changing, right? But then 0 0 means there is an odd cycle. Why? Because we can go above the tree, come down the tree, and then 0 0, it's an odd cycle. I cannot explain basic things very well. I don't want to do that. I don't want to waste time. I don't know why, but I don't want to do that. Okay. Okay, I will also take an edge W, and then I will form this adjacency list. Okay, again, I will also take points for, first let me clear that. I can just do that. But let me just do this. So we get go over all pace. So for I and j, we have W equals to, if, okay, not W, wait, let's keep it 8, wait. So our question is what? Is answer less than or equals to this thing, right? If this weight is greater than or equals to W, we add the edge here so that we our bipartite will answer if W less than or equals to W is possible or not. Then what do we do? Adjoint of I dot pushback of J. Or if I just keep it like J plus 1, J equals to I plus 1, then I can also add adjoint of J dot pushback of I. Then we are done. Now we can just put binary search our answer. So now we can just binary search our answer by int left equals to 0, right equals to 0 is always possible, right? 1e9. It can be 2 times 1e9 plus 4 times 1e9, right? So 1e9 is an upper bound for right. 1e9 is not possible, 0 is always possible. Answer less than or equals to 0. So answer is greater than or equals to 0. To non-empty. Still it works. For to non-empty it works. Left is impossible. You cannot have answer less than or equals to -1. Okay, you want the maximum possible thing. Right is impossible. Okay. Sorry, right is possible. Answer can be less than or equals to 9, 1e9. But left is impossible. Okay. If n comma mid comma, this answers me answer less than or equals to W, pause or not. Okay. If this happens, means you are able to split them into bipartite. Means answer less than or equals to mid is possible. Means right equals to mid. Else left equals to mid. So you have what is answer less than or equals to mid is possible. So you have to just return that. Right is the answer. Don't send that to. Okay, just have your n from here. Oh, wrong answer. Okay, our binary search is wrong. We want maximum possible, it seems, right? So where is it going wrong? Is binary searching wrong? Okay, this seems wrong. Answer less than or equals to x possible because we want the maximum possible answer, right? Okay, this seems wrong because now we know. Okay, it's entirely wrong. How can we do that? Okay, it is minimum. Okay, so it's reverse, guys. It's minimum. So I just have to reverse things now. So what does answer less than or equals to this means? Okay, answer greater than or equals to this means anything smaller than this should not be in the same group. Okay, so now let's say minus 1 is possible. Answer greater than or equals to minus 1 is possible. Okay, answer less than greater than or equals to 28 is impossible. Okay, now if it is possible, we do left equals to mid, else we do right equals to mid. We return left possible ones. I changed both of them somehow. I changed both of them. Okay, what happened here? Left is going to here. That should not be happening, right? Our question is, can answer be? Can answer be greater than or equals to x is our question. Okay. For answer to be greater than or equals to x, this should have our everything greater than or equals to, this should have everything greater than or equals to, anything less than x should be paid in different things. Okay. For answer to be greater than or equals to x, this should happen. And so this means, what does this mean? No, this you cannot do binary search. Let's just say we are brute forcing on. Why am I doing wrong like every time? I think we can brute force on. I can understand this is not answer greater than or equals to x. This is necessary, but then this is not sufficient. Okay, you take any, if the size of the things formed is greater than or equals to 2, then it becomes sufficient. Okay, so only when n equals to 2 there is a problem. Only when n equals to 2 there is a problem. Otherwise, you will have one of the size greater than or equals to 2, and then in that you have greater than or equals to x. Only if n equals to 2 there is a problem, and if n equals to 2 the answer can be 0. Everything is fine. I'll just submit it now. Otherwise, it's necessary and sufficient. Why? It's necessary and sufficient. Why? If n greater than 3, one side will always be of size greater than or equals to 2, and there you get an edge greater than or equals to x, and you have answer greater than or equals to x. So this is a necessary condition. If answer greater than or equals, this is a necessary condition, but then it's not sufficient, because you may have like this. Here it becomes sufficient, so it's a good problem. It's testing you were proving. Okay, I'm ending the contest. Bye. I'll end the stream too.